So hello everyone, this is Fractward, and today I'm going to make a small class for a friend of mine about functions that take in a vector and returns a vector. But first, for that, I'm going to make a scenario that will help understand exactly what's the purpose and how they are done. So, okay, what you see right now is a river. It may not look like it, but the y equals to 0 and y equals to 10 are lines that delimit the sides of the river. And the river goes through an infinite length horizontally. Just so we're clear with that, okay? So it's a river, and that small dot that is called B in the side right there is a boat. Our goal is to cross the boat to the other side of the river. Alright? So, okay. Well, that is not our goal exactly, but it is our goal, but like probably the model I have right now, you'll see. So yeah, we want to cross this boat towards the river. Actually, we will check if it's even possible to do so, because I think the example I did makes it impossible. So okay, the river though, it has a catch. Let's say we start here at 0, 0. So we haven't done anything yet. So we are still at the origin of the river. We are still like, just the origin of the river. We haven't done anything yet. We haven't moved. So I want to cross it. So we cross, like, let's say we cross to 5 meters. Alright. And okay, now the river has this funny thing that the more you cross it, the more you get pushed to the right by exactly the amount you have dislocated. So I dislocated 5 up. That means that I would be dislocated by the river 5 to the right. It's like so. 5, 5, 5. Okay? So we originally were at 5, 0, and the river sent us to 5, 5. Now let us imagine that I start here at a 5. The river, well, okay, I gotta figure this. On my finger, on my toe. I hurt my toe. Shit. Just gotta think real quick if I would do any change to the problem. Okay, no, I won't. Okay, so now let us. Okay, hold on. I'm thinking real quick. Okay. So let's say that like I am here at 5, 5. I'm here at 5, 5. Now, when you are more like when you go further from the center of the river, you also get pushed to the right. So we are currently 5 meters away from the river. So we get pushed 5. Okay? So we are at 10, 5 now. So we were originally here, and we went here. We also be pushed the 5 meters that was our position. So we're going to be pushed 15 here. So as you can see, the more you go through the river, the more you get sent to the right. And the more right you are to the river, the more you get sent to the right. So this is the problem of the river. And by the way, you'll see. You'll see. So, sorry that I'm doing this stupid thing, but yeah, okay. So this is the model of the problem. So how can we model exactly this change? Because I don't want to have to, move every time, my little thing here to the position that it should be. So what we can do is we can make a function. Notice that the position of the boat is represented by 2 values. That is 2 variables. The variable for x and the variable for y. So we can make a function that I'll call d for the location that takes in x and y. And we know that the more we are up, the more right we move. So we know that dx dy is gonna be, actually, hold on. Okay, let's let's I forgot to say something, that this is per second. So no, my bad, no, this is correct, it is I was being dumb. Okay, so like we are here at 505. So when we are here, we translate to 5. So let's say that I want a function that, given the current position, it tells me the next position I will be. So in this one, we are originally in our x, and then we move 5 times to the side. So we move y times to the side. And we know that also the more x we are, like the more to the right we are, we get pushed by the same amount to the right. So we do that y, actually my bad, this is x again, so it's 2x plus, and then the y, it will be just y, because we don't have any modification to y. I was going to add it at first when I was thinking of this example, but the problem is that they could go out of the river, and we don't want that for this example. So just manipulate x. It will get it'll still go through, so it's okay. So I may have gotten a waifu I want to enable die because I got pinged. I don't know where, but okay. So, oh my god, where the fuck am I looking? Where's Firefox? Oh my god, okay, there we go. So, this is the function that, given our current position, we get the new position. And to do that, I'm going to do something. Here, I'm going to do dots that will call C. This dot will be equals to, I think I can do this, b dot x and b dot y. Yep. So b dot x, b dot y, we do 2 times b dot x plus b dot y, b dot y. So this c right here is basically the vector, the resulting point of the function. So if we put it as 0, 0, you see that we have no location. The more we go up, you see that our boat would, the more we go up, go to the diagonal. And the more right we are, the more we get pushed to the right. So, yeah, this is basically what it is. So, we want to cross this river and get to 10, 0. No, 0, 10, my bad. We want to, from here, go to here. There's our goal. Now, this becomes quite easy because we have a function that is so 2x plus y that give us the position of the boat after it, like given the current position of it. So we can actually then choose a starting position. And I'm not gonna do this because I don't know exactly how I would go, but because this is not like continuous, this is actually a recursive problem. But still, we can, using this function, we can know the best starting position to start our boat that is not 0 in order to get to this point right here, which would actually require us to reach here at this point. The boat would have to be at like somewhere here, so that when it goes to right again, or well, whatever, I'm not gonna solve this example, but idea here is that, as you can see, this is how a function from a vector to a vector works. It takes in a vector and turns it into another vector. So this is not a requirement, like it is not required that the vector must be the same size. We can have a vector of size 2 becoming, let's say, like here, let me see, like x times y times x, you know, and then we have a vector of size 2 that is transformed into a vector of size 3, and each of these operations are done with the variables of the values of vector. I hope this made sense. Now, the Jacobian matrix that my friend was having problems with basically does the following. For each of these variables and for each of these functions, it takes the derivative in regards to this variable. So the first line, I believe, it is based on the difference. Okay, let's say the first line. I don't know exactly if I don't remember if it's the first line, but let's say the first line. So we first take in 2x plus y and take the derivative of it in regards to x. Then we do it in regards to y. Follow to the next equation, and we do the derivative of x derivative of y in regards to x and y in regards to y. And then the same for x plus times y times x. So sorry if this got a little bit scrubbly. Uh, just that my example wasn't as good as I thought. Yeah, well, it's not bad, but like the beginning one, the first version of it, you could say. But hopefully you understood. Hello, bye.